Hello folks, welcome to another episode of the video series where we learn Kotlin, following along with the Codecademy's Learn Kotlin track. And in the last episode, we were going through these conditional expressions and we completed half of it. Now let's get started and complete the rest of it. We were in the logical operators. So logical operators evaluate the relationship between two or more Boolean expressions and return a true or false value. So they are like the arithmetic operations or operators, but the difference is they don't work on numbers, they work on Boolean expressions so that you can combine multiple Boolean expressions in complex expressions using logical operators. There are several operators that we can use, which is the AND operator, OR operator, and NOT operator. Okay, this is AND, this is OR, and this is NOT or negation. The logical AND operator returns true if and only if the expressions on both sides of the operator return true. So we can see this here. When A is true and B is true, A and B is true. You might already familiar with logical expressions in AND or NOT operators if you had this class in college or in high school. So this is really the same thing, but in Kotlin syntax. So for example, if we have a variable called isSunny and it is true, and if we have a temp variable which is 85, we can write a complex condition using this logical operator. We can say if is sunny and temperature is greater than 80 degrees, then wear sunglasses. So to make this work, to make this line of code executed, both this is sunny and temp is greater than 80 needs to be true. If one of them is false, compiler, our program won't execute this piece of code, okay? Because this will evaluate into false. We can see that true and false is false, and false and true is also false. So to make AND return true, both sides of AND needs to be true, like this one here, true, true, and true. Since this sunny is true and temp has a value above 80, the expression inside the condition becomes true, so wear sunglasses is printed. The logical OR operator, you can see this table to understand it better, will only return true if at least one of the Boolean expressions being compared has a true value. So either this or this should be true in order this expression to be evaluated to true. So when A is true and B is true, A or B is true. And if one of the A and B is true, also the result will be true. But if both of them are false, then A or B is false. Okay, so in this example, it says if it's snowing or the temperature is less than 40, wear a scarf. Is snowing here is false. However, temperature is less than 40 is true. So the overall expression will be evaluated into true. So wear a scarf is printed. Cool. Now comes the logical NOT operator, denoted by an exclamation mark. And it'll evaluate the truth value of a Boolean expression and then return its inverse. For example, let's say is snowing is true. If we print not is snowing, then it'll print false. So not makes true false and false true. Okay, cool. So let's look at this example. If it's snowing or temp is less than 40, this is the same expression here, but now we negated the whole thing. We added a not, adding a pair of parentheses. Now this program won't have any output because this will be evaluated into true, and true get inversed or negated, and this whole expression altogether will be false. Since this is false, if expression does not execute this block, and this whole thing will be actually skipped and won't have any output. Cool. We already saw these tables. Now let's take a look at Logic KT, the exercise. I can maybe, make it bigger. Oh, yeah. So it says replace each underline underscore with a logical operator so that each expression evaluates to true and 4 statements are printed to the terminal. So for example, in this example, since A and B, one is true and one is false, we cannot use AND here. Maybe we can use OR. And here, not B is true. Since B is false, not B is true, and C is true. So we can use AND or here. I'm going to use AND. And here, A is true and D is false. So we need to use, again, OR. And here, not D is true. Okay? Not the D is true. We want this part to be false because the whole expression is negated. So if we want this whole thing to be true, we want this part in the parentheses to be false. And since this is true and B is false, the only way we can make this false is to add AND operator here, so that not D is true, true and false, true and false will be false, and then not false will be true. So since the overall expression will be evaluated into true, then wow will also be printed. Let's go ahead and run this program. Yes, all of the print statements are printed and we passed this exercise. Let's go to the next one. Now we can combine expressions containing logical operators to create even more complex Boolean expressions. When combining logical operators, the order of evaluation is as follows. First the parentheses, then not, and then and then or. Okay, so in this example, this part this whole thing will be evaluated first because it's in parentheses, and then this not also needs to be calculated, and afterwards we can evaluate the whole expression. So let's try to do that. Temp is greater than 40 is false. Is snowing is true. False or true is true. So this thing inside parentheses is true. And since is sunny is false, not is sunny is true. So this part is true and this part is true. True and true will be true, and the program will print where a code. Let's see this in this example step by step. This is the Boolean expression we are evaluating. This part between the parentheses is evaluated first, and then since this is true, the rest of the expression is not is sunny and true, and then not is evaluated into true, and now lastly true and true becomes true, and we get the final output where a code. So now the exercise time. It says use your understanding of logical operators and their order of execution, order of evaluation, to determine the value of the expression inside of the if expression. Cool. If you believe the program will output hello, set the value of expression value to true. If you believe the program will output goodbye, set the value of expression value to false. Finally, use println to output the value of expression value. So it needs the exercise needs us to first assign something to the expression value, either true or false. We will find that out, and then print this expression value. So we need to figure out if this is true or false by running this in our head. Okay, so I'm gonna start by doing this. This will become true, right? Because it is not false, so it means it's true. And then I'm gonna do this part. Not true means false. And then I need to do this parentheses, but since this parentheses has multiple operators, let's go ahead and do this first. False and true will be false, and false or true will be true. So this expression inside parentheses will be true, and lastly false and true becomes false. Okay, so I'm gonna undo, and I believe the expression value will be false. Let's try and see if we guessed correctly. Yes, it printed goodbye and then false, so we were correct. Okay, now this exercise we'll learn about nested conditionals. Actually, it is just like combining if-else statements by putting one into the body of another, so that it creates a nested structure. Okay, this is also something very commonly used in programming, so it's better we understand this really good. Similar to the concept of a dream inside of a dream from the movie Inception, a conditional can exist inside of another conditional. This occurrence is called a nested conditional. By nesting a conditional inside of another conditional, we can achieve more complex and precise logical solutions. For example, remember conditional Greek? We can use a nested conditional to replicate this situation. I doubt you remember conditional Greek. Even I forgot about it. It was this like river branching out, and there were some banners or like flags, which some was pointed, some was striped and such. But yeah, so here let's try to understand this. I'm gonna copy this. Okay, I'm gonna copy this so that I can work on this. Okay, so when you see this code, you need to understand the structure of it. You should be able to see that this if-else statement is together. Like your eyes need to group this if-else statement because they are indented, and these if is matching with this else. Okay, so if you cut this part out, we will again paste it soon, but when we cut that part, you can see that there is another if-else statement, and the part I cut out was just some block of code inside this if block. Okay, it's not a different or a new concept. Like nested conditionals is not a new concept, but it's just like a combination of our knowledge. So we already know how if else works, and now we come here and instead of adding one line of code, we add another if else block here, okay, like this. So for example, to make this work, this if needs to work so that this code should be executed, and then this if else block is executed, and then if this conditional is also true, then this will be executed. Let's go ahead and try to understand by reading more of the instructions. The first conditional checks the truth value of sailor color. Yes, the first conditional is this. While the nested conditional, this one, checks the truth value of sail pattern. This program will output the following. Follow the lower river, then take the right path. How? Because sail color is red. So when we say sail color is red, if we check that, you can see that this is true. And since this is true, the else block won't be executed. Then this println will be executed. And then here comes another if else. And in this if else, now it checks sail pattern to be stripe or not. Since this is stripe, then this piece of code will be executed and this one will be skipped. So this, then take the right path, is outputted here. Cool. Now let's try to do the exercise here. In order to be considered a planet, a celestial body must accomplish 3 things according to the International Astronomical Union. One condition, the first condition, is that it must orbit a star like the sun, and the second one must have enough mass in order to achieve hydrostatic equilibrium like a nearly round shape, and third, it must have enough mass to clear debris or small objects from its orbit. This is pronounced debris, right? Yeah, debris. Cool. Enough Star Trek. Cool. The difference between a planet and a dwarf planet comes from rule 3. In planet KT, create an if expression. Yeah, I already know how to create them. If, then a pair of parentheses, and it should check if orbits star. Orbit star is a boolean. And hydrostatic equilibrium are true. So I need to put and here I will say hydrostatic equilibrium. So now both of them, when both of them are true, the code at line 8 will be executed. It says leave the body of if expression blank for now. Yeah, I already left it blank, and running this program will make us pass the first task. And second, inside the if expression, create a nested conditional that checks if the value of cleared orbit is true. Another if, and here inside we check cleared orbit is true. Okay. And if this is true, we need to create a println statement inside. We need to print celestial body is a planet. Cool. Let's run this. We also passed this one, but as you can see, this is not printed because this and this is true, but cleared orbit is false. So we couldn't pass rule 3 and hence couldn't print this statement. Underneath the nested if expression here, create an else expression. And inside, we should output celestial body is a dwarf planet like Pluto, for example. Println celestial body is a dwarf planet. Let's run this. Yay. So we passed this one as well. Now comes the when expression. When is a real good expression. I really like it because it's the first time I see such an expression in Kotlin. Now it's time to see when expressions. I really like when expressions because it's one of the fun features of Kotlin language. Usually in other languages like Java or C or C++, or Python maybe, there is a structure called switch case. Okay, they are more or less the same in different languages. But here in Kotlin, there is no switch case statement, but there is this when statement, which is similar, but is really, really better than those structures. So learning this when statement, you can create multi-branch decision trees or conditionals without chaining lots of ugly if-else statements. Okay, so let's go ahead and read this and see what Codecademy curriculum developers have written for us. Another expression that controls the flow of execution in a program is the when expression. A when expression is made up of multiple branches that contain values or arguments to check for. If the value of the variable being evaluated matches one of the branch's arguments, the instructions contained in that branch will be executed. What does it mean? It's like a very long sentence. Let me tell you what. So it'll check the light color, which is a string, and if this string matches with this one, it'll do this and forget the rest. If it's yellow, it'll do this and forget the rest. If it's red, then it'll do this and forget the rest. If none of these are true, then here comes the else to save the day, and it'll print the last thing, or it'll do the last expression given here. So this one prints stop because the light color is red and it doesn't get matched with green and yellow, and lastly it matched with red, so this expression works and not others. Cool. The keyword when is followed by a variable placed within parentheses. The setup for each branch starts with a value to check for, an arrow, and then an instruction to execute. So these are specific individual branches, and here this is the arrow. This is really cool, by the way. The else at the end of a when expression, this one, is an optional addition that can be used to catch any unexpected or additional values the variable being evaluated could contain. In the example above, the value of light color was red, so the instruction println stop was executed. Programmers often use when expressions in lieu of if, else, else if conditionals because of their significantly shorter syntax. Yes, that is why I like it. It's really looking good on the eye, and it's significantly shorter. For example, we can create a when expression that evaluates multiple expressions. Yeah, this is another syntax. See, here we use when and then a pair of parentheses, and we put some expression inside this parentheses. But here there is no parentheses, so this is a different syntax than this one. It's like another variation of when statement. Here it tries to match this light color with this. But here in this example, it is just check if any of the branches evaluates into true, and if not, then it picks the else statement. For example, the num is 19, so it'll check num is less than 0. If this is true, if this Boolean expression is true, then it'll do this one. If it's equal to 0, it'll do this one. If it's greater than 0, it'll do this one. And if none of these work, then it'll run the last part, last branch, following the else condition. So this is really cool. You may need to take a note of these two different syntaxes. The first one has a when and then a pair of parentheses, and then here some possible values. This can be string, for example, because this is a string, and it can be an else statement. But in this variation of when, there is no parentheses, nothing to check here, but instead it checks if each of the branch has true or false, like an if statement combined with else ifs, and this kind of chain. Note that how in the example above we didn't place a value inside parentheses after the when keyword, and instead placed full expressions inside the branch's arguments. So this is called the branch argument. Okay. To explore other ways we can implement a when expression in our programs, check out the Kotlin language guide. And just having a quick look, you can see that there are other cool ways of using this. For example, after the arrow, you can use a pair of curly brackets to create a block of code. Or we can combine multiple arguments in one line. Or we can place arbitrary expressions, not only constants, to the arguments. Or we can use this kind of in or not in values to check if something is in range or a collection. We will see these ranges later on in Codecademy. Or we can use something with is, or like as a replacement of if, else, if chains, so full expressions here. So lots of different things can be done with when. So let's go ahead and try to solve this assignment. We're going to create a program that determines what kind of crop to grow based on the season. Create a when expression that evaluates the value of variable season. When the value of season is winter, then print grow kale. If it's spring, then lettuce. If it's summer, then corn. If fall, then pumpkins. Add an else expression that prints not a valid season. So we need to create a when expression. Which one should we use? The one with the parentheses or not? Since it'll check the value of season, we'll use the one with parentheses because it's like checking one expression to match all different branches with different arguments. So if it's winter, then we want to print grow kale. I'm gonna copy and paste so that I can quickly copy and paste those. So when it's summer, then it's corn. If it's fall, then it's pumpkins. Cool. And then it says add a remaining else branch here that prints not a valid season. So print not a valid season. Cool, let's run this and see if it's work. It didn't work. Why is that? Let's try to understand. There is no syntax errors, right? because there's nothing printed to the console. But there is a problem on Codecademy's side. It says, did you create a branch that checks if season has a value of winter and has an instruction to print the statement grow kale? Actually, you know what? I did exactly what it says. Let me think a little bit. It says grow kale. This is a when statement, when expression. It checks the season has a value winter. What did we do wrong? It is really similar to this one, no? Maybe because of the println, they were expecting us to write println and I just went ahead and write print. Maybe that is the reason. Let's try to run again and see if it was the error. Yes, actually, it was the error. So I need to report this to Codecademy team. Let me copy this link so that I can remember later. And then I can create a report to Codecademy. Cool. And there is an optional task. It says take some time to experiment with your code by changing the value of season. Yeah, it's an easy thing to do. If it's summer, then it'll say grow corn. And if it's blah, 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 which doesn't look like or sound like a season, then the else branch will be executed. And it'll say us, blah, blah, blah is not a valid season. Cool. And we could also, actually, we already passed this one. So for fun, we could do this thing. Season is not a valid season, so that it's more fun to read. Oops. I just want to see that. Yeah, bring my code back. Yeah, run. Blah, blah, blah is not a valid season. Thank you. Okay, next. Now it is the last exercise before the review, I guess. So we're gonna learn range. Cool? It was actually what we saw on here. We were checking some x to be inside a range or not. So let's learn about it. Range. In Kotlin, range provides a powerful tool that represents a consecutive succession of values that can often be used in conjunction with conditionals. Whew, it was a long sentence, and here it's almost midnight, so I'm having a hard time understanding it. So let me give 30-second break and drink some water and try to focus. Okay, range. In Kotlin, range provides a powerful tool that represents a consecutive succession of values that can be often be used in conjunction with conditionals. Okay, like lots of fancy words. Let's try to understand what does it mean. It says in Kotlin there is something called range. Range is a powerful tool, and range represents a consecutive succession of values. A consecutive succession of values like 1, 2, 3, 4, 5, or A, B, C, D, E, F, G, or similar, okay? And ranges can be used with conditionals, okay? So breaking that sentence apart in 5 different shorter sentences, now everything makes more sense, actually, to my tired brain. So in Kotlin, ranges are created using dot, dot, or double dot operator. It starts by a starting value, then double dot and ending value. An example is this. For example, 1 dot dot 10 is create the range of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And both of the values are included in this range. So it's not like starting from 1 and ending in 9. 10 is also included. 1 is also included. We can check if values are contained within a specified range, within a specific range, with the help of in keywords. So we can type this kind of things. If number is in 1 to 10 range. And since number is 5, this will be true because 5 is in between 1 and 10. Okay, so this will print this value is between 1 and 10. The in keyword is used to check if a value exists inside of a collection or range. The program above checks if num exists within the range of 1 through 10. We can also check if a character or a char value appears inside of a range. So let's say the letter is C. Please note that this is a char and these are single quotes. That's where we know it. And now it put the letter variable inside when. So now we can write things like when letter is in A to M range, then we print letter is in the first half of alphabet. Or if it is between N and Z, then we print letter is in the second half of the alphabet. And if neither of them is true, then it prints not a valid value. Cool. And also there's a note here, letter ranges are case sensitive. So let's go back and write some more code. There is a scale called Scoville Scale. This is a scale that measures how peppers are, how hot are the peppers. Okay, so it's used to measure the heat or pungency of a pepper. Use if, else if, and else expression. I would rather use when, but yeah. Use if, else if, and else expression to determine the pungency of a chili pepper based on the pepper's Scoville heat units. Cool. If the value of SHU is between, I think it is short for Scoville heat unit. Yeah, Scoville heat unit. If it's between this and this, set pungency to very mild. And if it's between this and this, then the mild, and the moderate, the high, and very high. Let's go ahead and do that. If SHU in 0699, don't forget space here, then set pungency to very mild. Else if the SHU is in 700 to 2999, then pungency is mild. Else if the SHU is in 3,000 to almost 25,000, then pungency is moderate. else, oh, come on, I hate if else chains. Else if pungency, not pungency, SHU is in between 25,000 to 69,999, then pungency is high. Is high. And else pungency is very high. Let's run this. It was tedious to write all of these branches, but we passed it. And as a last exercise, it wants us to print this string using println. A pepper with SHU, Scoville heat units, has a moderate or high or very high pungency. Let's run this. Okay, cool. We passed this. But before we finish up this video, I want to show you something. Let me copy this. And then let me open IntelliJ IDEA. Yeah, here. And I'm gonna use presentation mode for that. So that you can see better. Now I'm gonna pass this code, okay, creating the variables SHU, which was, okay, I can just copy here. Now, as you can see, this tedious work of writing all this thing actually can be very easy with when syntax. And IntelliJ IDEA offers us an automatic way of converting this into when expression. What I'm gonna do is I'm gonna use Option Enter, and then I will say replace if with when. And when we do that, you can see now it is much more readable, and even we can make this even better. And I'm gonna show you how. So to make this even better, I can get rid of this blocks of code by using remove braces from when entry. I'm gonna do the same here, 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 and here. And now I can lift the whole thing out. See, since when is an expression, it will return what is written here into the whole expression. So the whole expression will be evaluated into either very mild or moderate or high or very high, and the end result looks like this. Whereas compare this with this monstrosity. Okay, like which one is more readable to you? For me, it is this one. This is really readable, and you see the range and the result, range and the result, range and the result, and look at the arrows. I love the arrows. Cool. This was just bonus information. I won't go into the detail of how this works and such, but you should know that when can be very efficient and shorter in terms of syntax and keystrokes, so that it'll save you some time. Let's go ahead to the review. and then close the video. What we have learned in these past two videos. We learned that conditional expressions control the flow of execution in a program, and if expression executes a block of code when the value of its condition is true, and else expression executes code when none of the previous expressions have a true value. We have comparison operators like greater than, less than, greater than or equal to, and less than or equal to, and they are used to compare two values to determine a true or false value. There is this equals operator, which is really different than the equals operator. Equals operator means like one equals means assignment, but two equal sign means there is an equality check. So it'll check if the right hand side and left hand side are equal, and it'll return a true or false, okay, as a result. And there is also a exclamation mark equals or bang equals, and this checks if two values are not equal. There is logical and or and not operators, which will modify, which allows us to combine multiple Boolean expressions or create more complex Boolean expressions. And we also saw if-else chains, if, else if chains. And else if expressions are used to add more conditions to a traditional if-else statement, because a traditional if-else statement has only two possible branches. But if you use if-else chain, then you have much more branches. A nested conditional is a conditional that appears inside of another conditional. So using that nested conditional, you can also create multiple branches. But the best way of creating multiple branches, in my opinion, is using a when expression, usually, okay? A when expression evaluates the value of a variable or expression in order to dictate the flow of a program. The range operator, ... creates a consecutive succession of values. Nice. It says use the space in review KT to practice the content learned in this section or lesson. But I'm gonna use this to promote myself. Okay, folks, if you like the work I do, if you like this video, go ahead and follow me on Twitter as well. And if you're not watching this video on YouTube, my YouTube is youtube.link/Safa. And if you want to get a YouTube link like this to your YouTube channel URL, visit getyoutube.link, and you can get it for $1 forever if I haven't changed my mind on the pricing. Okay, so thank you for watching this much and coming to the end of this video. See you in the next episode.